Our first video here, we're going to take a look at the exponential application of compound interest. We have two different formulas that you should be familiar with. The first formula has the initial amount, a rate, compounding period, which is our n, and then our time. And then in our second, our compounding continuously formula, E is our optimized amount or value for this inside part here. So in that formula, we just have the rate, time, and the initial amount that's going in. So our first scenario, we are going to invest $8,000 for 6 years, and we have two choices. So we're going to have two parts to this situation. Our P is $8,000 for both, and our time is 6 years for both. Our first scenario, the rate is 0.07, and we have our compounding monthly, so our n is 12. We're going to use our first formula, 8,000 times 1 plus 0.07 divided by 12 to the 12 times 6. As long as you're solving for that final amount, these are not too bad. You can type that straight into your calculator to get that final answer. So there's no issue with exact values here. You should be getting your exact answer. And obviously you're rounding, so there's a little bit of approximation. Our second asks you to check and see if compounding continuously is better, but it's at a lower rate. So it's e to the 0.0685 times 6, because that's our new rate. And although it is the optimized amount, it would only be better to do compounding continuously if you're at the same rate. So in this case, the first account is the better investment. Now in our second scenario, we'll do a little bit of the same, because we're going to be able to type in something all in one shot, but then we're also going to have to solve using our logarithm techniques. So our starting amount is $2,000. We're starting in the year 2000, so we're going to go up from there when we're plugging our information in. So we're starting at $2,000, plugging this into an IRA at a rate of 0.10. So back in 2000, there were rates that were this high for some of these different things. Now rates are a lot lower on a lot of these different accounts. And then the time, so we're compounding continuously. We know that we're going to be using that first formula, or second formula actually. We want to know what it's going to be worth in 2020, so that means we're looking at 20 years from the initial investment. So 2,000 e to the 0.1 times 20. And over that 20-year time, the money grows to be $14,778.11. Not a bad investment there. If you were able to keep it at the same rate, the next part says when will it be worth $20,000. So now we have A is the 20,000. So we're going to have to do some solving work here. We have 20,000. Just be careful with your zeros on this. Equals 2,000 e to the 0.1 times your time. First divide out your 2,000, you get 10 equals e to the 0.10 t. Take the ln of both sides. Remember, ln of e is equal to 1. Divide out that 0.10, so we get 23.03 years. This should also be something that's fairly easy to keep exact, because if you're going to your calculator, you're just doing ln 10 divided by 0.1, because that was an exact answer that we could work with. Okay, that wraps it up for this video. In our next video, we'll look at some exponential growth and decay and some other scenarios where we have to create some new formulas.